Okay, part 2 of section P.4. I actually left out 2 topics last time. For some reason, I don't know, I just forgot to talk about simplifying radicals. So this video has 2 topics. We're going to simplify radicals, and then we're going to talk about rationalizing. So simplifying radicals, we're talking about things like writing a radical in simplest form. So if we have something like the cube x cubed, okay, we can write that in a more simple form. One thing to take note of, that we could rewrite this as x times x times x to get x cubed, because we would add those exponents and get x to the third. The idea here is that anytime that we have a number of factors inside our radical that matches the index on our radical, so here we've got 3 x's and our index is 3, and that means we can get rid of the radical. The radical and the exponents will cancel out. So here, the cube root of x to the third, that is just x. One disclaimer here is that you do have to be a little bit careful, because a lot of you probably learned that the square root of x squared equals x. It actually doesn't. It's actually the absolute value of x. That's something you run into when you're dealing with even indexes. We're not going to worry about that, so you're not going to have to worry about absolute value on any of the problems that I give you. Okay, so just know that sometimes you have to throw absolute value in, but you don't have to worry about it. So let's think about if we have something a little more complicated. Maybe we'll stick with cube root just because it's small. Think about, we've got cube root of x to the 4th, y to the 5th. Okay, what we're looking for is we're looking for factors with groups of 3. And because every time we have a group of 3, we can take the cube root and we get whatever factor out front. So something I like to do when I have a number part, I like to bring it over to the side and find its prime factorization. So what that means is I'm just breaking it down into prime numbers. So I do a little factor tree. So 16 is 2 times 8. 8 is 2 times 4. 2 times 2. And 2 is a prime number, so we could rewrite 16 as 2 times 2 times 2 times 2. 2 to the 4th power. So if we rewrite here, do each term, but we started with the numerical part. So we've got 2 to the 4th power, x to the 4th power, y to the 5th power. And our exponents 4, 4, and 5 are all bigger than 3, so that means we can break this down and get a power of 3 out of each one of these. So 2 to the 4th could be 2 to the 3rd times 2, 2 to the 1st if you want to. And for the x's, we could say, well, we've got 4 of them, so we could get a group of 3, a group of 1, and then with the y's, we could get a group of 3, a group of 2. Because if we multiply this back out, we're going to add our exponents. So 2 to the 3rd times 2 to the 1st would be 2 to the 4th. X cubed times x would be x to the 4th. Y cubed times y squared would be y to the 5th. Then we go back to that important fact, right? So here's a group of 3. Here's a group of 3. Here's a group of 3. So we can simplify those parts. So the cube root of 2 cubed is 2. That's this one. The cube root of x to the 3rd is x. And the cube root of y to the 3rd is y. And then everything else is still going to be under the radical. So what do we have left? We have 2, x, and a squared. Okay, so cube root of 16 x to the 4th y to the 5th simplifies to 2xy cube root of 2x y squared. Okay, we just bring out everything, all the powers of 3 that we can. Okay, and you can have a situation like this where We'll just stick with the cube root. It's not always a 3 out there, but we have like x to the 11th. Sometimes we can break that down into more than one power of 3. So x to the 11th, take out 3, still got an 8. Get another 3 out of that, so we're up to 6. We can get another x to the 3rd, we're up to 9. So to get to 11, we'll have 2 left over. We're at 3 plus 3 plus 3 plus 2 is 11. So for each one of these factors of x cubed, taking the cubed root, so we're going to bring an x out. So for this one, we'll have an x. This one will have an x. This one will have an x. And then everything else is still underneath the cube root, so we'll have cube root of x squared left over. And then we can multiply the x's out front. Right, so we'll end up with x cubed cube root of x squared. Let's do one more, and I'll do a different index this time. Let's do, let's see, we'll do the 5th root of 24, x to the 7th, so if I'm doing this, I'm going to come over and find my prime factorization of 24. 2 times 12. 12 is 2 times 6. 6 is 2 times 3. But look at this. The most number of factors we have, we've got 3 2's, but our index is 5, so we don't have enough to get a group of 5 2's there. So 24 is just going to stay. And because we don't have enough of any particular factor, we would have to have 5 of some factor to bring one out, but we don't have enough. So 24 is just going to stay underneath the radical. Okay, so knowing that 24 stays under there, then x to the 7th can break down as x to the 5th times x squared. Then what about y to the 4th? 4 is smaller than 5, so there's nothing we can do with that. Y to the 4th is just going to stay under there. So the only term we can simplify here is x to the 5th term. So the 5th root of x to the 5th is going to give us an x out front. Everything else is going to stay underneath. 24, nothing we can do with that. An x squared, got a y to the 4th. That's as simple as we can make that. Okay. So now let's talk about rationalizing. Rationalizing is what we call it when we are getting radicals out of the denominator. Okay, so if we have a fraction and it has a radical in the denominator, then sometimes we say we want to rationalize it or get the radical out of the denominator. So we have something like 1 over square root of x. So here we've got a radical in the denominator, and sometimes that's inconvenient. So we want to rationalize. And the idea here is we're going to multiply by some form of 1. And remember, anything over itself is 1. So as long as we write the same thing on the top and the bottom, when we multiply, we're not going to change the value of the thing we're multiplying by. We might change how it looks, but we're not going to change its value. Okay, so here we want to come up with something, top and the bottom. It's got to be the same on top and the bottom, that we can multiply by here that will make that square root of x in the bottom cancel out. Okay? And if you just have a square root, that one's pretty easy because all you do is you multiply a square root of x over square root of x. And why does that work? Well, on top we've got 1 times square root of x, which is square root of x. On the bottom, our rule if we're multiplying radicals together is that we multiply the numbers underneath the radical together, or in this case the variables. So we have square root, and then we have x times x, so we get x squared. And in this case we're going to pretend like we don't have to worry about the absolute value, and we're going to say our variables represent some positive number, I think, which is usually how you get taught these things. So what happens with square root of x squared? Well, that goes away, so we're going to have square root of x, and square root of x squared just turns into x. Okay. And you can do the same thing with numbers, so put a 2 on the top this time. So how about 2 over square root of 3? So we'll multiply by square root of 3, square root of 3. Top, the way you do that multiplication is you treat this radical like a variable, so we'll have 2 square root of 3. In the bottom, we'll have square root of 3 times 3, which is 9. And the square root of 9, that's a perfect square, so we end up with, so 2 over square root of 3, same thing as 2 root 3. Okay. What about if you have something that's not just a square root? We have something like over the cube root of x. Well, same trick, we're going to multiply by something over itself, but what do we need to multiply x by so that we can get it out from underneath the cube root? About that for a second. You try just cube root of x. That's not going to work because we're going to get cube root of x squared. So what do we need to do? We need to increase our exponent here. That way we end up with 3 x's. So now when we multiply, we'll get cube root of x squared on the top. Bottom, we've got x times x squared. Get cube root of x cubed. Cube root of x cubed. X. X there. Alright, so hopefully that'll get you through the rest of the section. I misspoke in the last video and thought we only had one topic, but we had these 2 other smaller topics left. Send me an email or message if you have any questions.